Hello everyone, my name is Dhruv Patel and today I will be presenting project 2 from the class of Design and Manufacturing taught by Professor Hassan Rashidi at Georgia Tech. And today I'll be talking about additive engineering. Some of you might know this as 3D printing, but that's just one of the processes of additive engineering. So a quick overview of the agenda for this presentation. I will be explaining what this concept is and how it is being applied into the real world, what the impact it has, and how it is affecting the current market, as well as how to use this and where you can find this information at. So a quick explanation to additive engineering. Many people already know it as 3D printing, and there is a whole different science and techniques behind 3D printers and designing for printing, but we're looking at the grand scope of additive engineering as a whole. 3D printing just encompasses this concept. Additive engineering is the process of adding material layer by layer to create an object from digital 3D models, which means most digital 3D designs can be printed into real life products for examination, and there is a whole design science behind 3D printing as well. This is widely used in aerospace industry, automotive industry, healthcare industry, and even consumer products to reduce cost of production, as well as it is also used for rapid prototyping and even testing in some cases. This type of engineering has a wide market, massive market for especially rapid prototyping, as I mentioned, and even improving design processes. So how efficient is the design process? With the use of 3D printing, an immense amount of time is saved, as well as immense amount of waste can also be prevented due to its on-demand production capability, as well as its sustainability approaches. Most 3D models are able to come to life within days, if not hours, depending on the size and the material of the model. And the best part is, all materials are recyclable and can be used again for printing. So over application, the use of additive engineering allows for rapid prototyping, meaning that designers can quickly create functional prototypes without waiting for large lead times or even costly toolings, which are used in traditional ways. Fun fact: I worked at a lighting company known as Signify, or you guys might know it as Philip Lighting, and I often saw a lot of 3D printing parts when testing the fixtures in the ceiling, whether it is in the mounts or even the housings. And I also worked on a project for them where I created like a showcase box by 3D printing it, and the box fitted products to show to the customers in meetings. This reduced major lead time and didn't require tooling for the boxies or even acquiring them from different companies. So if it were traditional showcase box with the foam rather than 3D printed skeleton, it would generally take 2 to 3 months rather than 1 week to get it. Anyways, this type of engineering can be used for personalization and even custom products for consumers, and even medical products such as implants or even hearing aids and prosthetics. It plays a big role in healthcare industry. Finally, this engineering enables small-scale production at a lower cost compared to traditional methods. So a prime example of exploiting this method is in GE Aviation, which uses 3D printing to produce lightweight attachments, but they're strong fuel nozzles for jet engines. In terms of innovative approaches and impact of additive engineering, a huge contribution is from 3D printing industry currently, which offers a wide range of accessibility for materials such as plastic, like PLA or ABS, and even metal production at a small amount of time. Using titanium or even aluminum. These materials are quick to print and cheap to produce. However, limitations do arise when using high-end multi-material and resin printers, as materials for those printers get extremely expensive, even with the fact that prices are decreasing nowadays. Though these printers do provide incredible technology of printing flexible parts, this is widely used in prototyping and even small-scale productions. The fact that companies are able to reduce lead time and cost by utilizing additive engineering creates a loop. And the loop is that a company gets into the industry for speed and efficiency, likes the additive industry, invests in research in this industry, and then technology keeps getting better and better, and the cycle continues. I think that this industry will only get larger and bring about the biggest impact to automation, manufacturing, and those practices. Now, currently, the market of additive engineering has been constantly evolving in the past few years, and it is slowly turning into an option for even mass production. For today's companies like Carbon 3D, they're offering industrial printers for production, and many companies in aerospace and automotive industries are already starting to use them. Nowadays, while AI has been established in today's time, it is still an emerging and constantly improving industry. Now, it is being implemented into additive engineering for creating smarter manufacturing processes, more efficient processes, and doing so with minimal waste and energy. AI-based printing and AI-based printing and production will be constantly improving in the near future, and the effects are already being seen in many products. Considering all the benefits and limitations, this market does have a high skills ceiling in terms of actually utilizing the technology. So all methods of additive engineering, if not all of them, if not some of them, use some sort of computer-aided design to form a 3D model digitally, which then can be replicated layer by layer into real-life products. Most people are not equipped with the software, or are just really expensive to buy, or some of them will not understand how to use the software or even design techniques for 3D printing. And with increasing automation, machine learning and AI has been playing a big part in the skill needed to take part in this market. And again, most people are not comfortable with that. Therefore, I think the loop previously mentioned continues. Companies invest in experts and technology, conducts research, and then presents results, and the cycle continues. And these are my sources. If you want to learn more about this information and still have questions unanswered, feel free to take a look at these sources. The first two are extremely resourceful on this concept, and if you like exploring products, you should learn more about Carbon 3D, which is the last source in here, and about what they do. I think they're awesome. Thank you so much for listening and learning with me. I hope that you can walk away with a little bit more knowledge about additive engineering than you knew before. And thank you again. Bye-bye.